All right, hi guys. Here is the Unit 4 study guide. Okay, the angle measures of an equilateral triangle will be 60 degrees, right? If all sides are equal, then all angles are going to be equal. And the best name for a triangle with a measure of 45, 45, 90, or 45, 90, 45 would be an isosceles, right? Because you have two equal angles. I spelled that wrong. Lee's right triangle. Angle. Man, talking and writing right now, not working for me. Okay, and then obtuse triangles will have one measure that is greater than 90 degrees, and the other two angles will be less than 90 degrees. Okay, so we're going here. Triangle ABC is congruent to triangle PQR. Well, it says R is congruent, and you're going to look at the order. Since R is the last in the order, that means it has to be congruent to angle C. And then for triangle ABC, name the side opposite BC. Name the angle opposite BC. So we're going to look right here where BC is, and the angle opposite that side is going to be angle A. My suggestion to you would be to make sure that you draw a diagram. All interior angles of a triangle will have the sum of 180. Some of this is review. And CPCTC stands for corresponding parts of congruent triangles, forgive my shorthand there, are congruent. Okay, let's refer to the diagram and complete the following statements. The legs of the right triangle, so let's go ahead and identify them. Here's our right triangle right there, ADB or ABD. The legs, they make up the right angle, so your legs would be AD and DB. The hypotenuse of the right triangle, well, the hypotenuse is always directly across from the 90-degree angle, so your hypotenuse would be AB. All right, and then the vertex would have to be right here, this angle, because it's where the two congruent sides come together. So you could either call it angle BAC, or you could call it angle CAB. All right, because we've got to specify that it's right there where I highlighted in the aqua. And it's the vertex, specifically because a specific vertex is always in an isosceles triangle. So these two congruent sides where they meet would be right here. The base angles of the isosceles triangles, so down here, these are going to be congruent. I'm going to just say angle ACB, so right there, and angle ABC. Okay, now name the side opposite angle CBA. So CBA is this angle right here, and the side opposite would be right here, this side right there. And I'm just going to say CA. Yep. And if you could see it, that would be even more helpful. Okay, next up, all right, triangle BLT. The BLT, here we go. I'm going to do B, L, and T. And I'm going to go ahead and kind of fill in the information they give me. So angle B is equal to x plus 42. Angle L is equal to 3x minus 18. And angle T is equal to negative 2x plus 134. Okay, so what I'm going to do is I'm going to add these three angles together and set them equal to 180. So I'm going to do x plus 42 plus 3x minus 18, close my parentheses, plus negative 2x plus 134 equals 180. I'm going to combine my like terms, and then I will simplify. So I'm going to get 2x plus 158 equals 180. 2x equals 22, and x equals 11. Sorry for the little typo there. X equals 11. Okay, well this triangle, these dashes right here show me that this is an isosceles triangle and the base angles are going to be congruent. So if L is 2x plus 49 and M is 5x minus 53, they want me to go ahead and solve for x and the measure of angle P. So what I'm going to do first is I'm just going to set these equal. Wait, L and M. Oh, oops, sorry, that's not M. This is angle M, which is up here, which is 5x minus 53. But we know these two are congruent, right? So I'm going to do 2 times 2x plus 49, and then add 5x plus 53, and we'll get 180 degrees. Okay, so I'm going to simplify by distributing first and get 4x plus 98 plus 5x minus 53 equals 180, right? Combine some like terms, get 9x plus 45 equals 180. Simplify 9x to equal 135 and get x to equal 15. Well, it wants me to find P, but I know L and P are the same measure, so I'm going to just plug this x in here. And I'm going to say angle L, which is the same as angle P, P or L, is going to be equal to 2 times 15 plus 49, which should be about 79 degrees. Okay, so next up, the perimeter of triangle LMP is equal to 53. So it's going to be equal to 53. I know that LM is 2x plus 5, and LP is equal to x minus 17. Well, I also know that if this is 2x plus 5, then this is 2x plus 5, because they are the same, being an isosceles triangle. So what I'm going to do is I'm going to combine my like terms. So 2x plus x, I'm going to get 5x. Positive 5 minus 17 is going to give me negative 7, not negative 17. Minus 7, and I know it's going to be equal to the perimeter, which is 53. Okay, so I'm going to have 5x equals 60, and x equals 12. Well, it wants me to solve for MP, so I'm just going to go 2 times 12 plus 5 and get 24 plus 5, which is 29. Okay, so this one looks a lot trickier than it is. But what we are going to realize is that right here, angle A is 33 degrees, angle E is 68 degrees, and angle AEG, this angle right here, is 45x minus 23. Well, this is kind of silly because it wants you to find the measure of angle AEG, which is technically this angle right here. Well, I think this must be a typo because together these two angles, they form a straight line. So in order to find it, I'm just going to do 180 minus 63. and I'm going to get 112. And that's what that angle measure would be. Now we are going to flip the page, turn the paging, and we're going to find the measure of x and the measure of angle A. So angle A, this time, it's going to be a little bit more challenging. Is 3x plus 2. Angle D, which is right here, is 5x minus 1. And then the angle out here, AEG, is going to be equal to 128. So this is the remote exterior angle theorem, if you guys remember, which is where we add these two angles together and they equal this exterior angle. So we are going to do 3x plus 2 plus 5x minus 1, and it's going to equal 128. So I'm going to combine like terms. I'm going to get 8x plus 1, right? Because 2 minus 1 equals 128, and get 8x equals 127. And maybe I made a mistake, but I got a decimal. I got x equals 15.88. So 15.88. But now what I'm going to do is I'm going to plug it into angle A. So A, I'm going to go ahead and solve for. So I'm going to do 3 times 15.88 plus 2, and I'm going to get 49.64. Hopefully I didn't mess that up. Next up, ABC is an equilateral triangle, so that means all of these angles are going to be the same. They're all equal to 60 degrees. The measure for angle C, so A, B, C, is equal to 6x minus 12. So we're going to do 6x minus 12 equals 60, because each angle is equal to 60. And then they want me to solve for x. So I'm going to have 6x equals 72, divide by 6, and get x equals 12. Guess maybe I'll zoom out here a little bit. So maybe that will make it a little easier to see. Okay, this time, triangle ABC, ABC. AB is equal to 3x minus 13. And the perimeter is equal to 33. So it's an equilateral triangle, right? That means all three sides are the same. So I'm going to do 3 parentheses to represent the three sides. So 3x minus 13. And I'm going to set it equal to the perimeter. So all three of these sides may equal 33. So 9x minus 39 equals 33. And I'm going to go ahead and get, oh, you know what else I could do, which might be a little bit easier? So that's one way. The other way would be knowing that each of these sides is equal, so taking 33, dividing it by 3, and getting 11. Now I can just take that one side, 3x minus 13, set it equal to 11. And I'll get 3x equals 24, and x equals 8. Okay, moving along. What type of triangle is this? All three sides are congruent, so it would be an equilateral triangle. I'm going to do 8x minus 44, set it equal to 60. I'll move the 44 over and get 8x equals 104, divide by 8 and get x equals 13. Moving right along, we know that triangle DEF, so DEF is congruent to triangle LKM. All right. I know that D and L, they're going to be congruent to each other because they're both first in the order. E and K, because they're both second and lastly F. So I'm going to use the congruence information to help me solve for X and Y. All right, first up, D is equal to 9X minus 61. K is equal to 39. L, this guy right here, is equal to 5X plus 3. And F, down here, is equal to 14Y minus 12. Well, I'm going to start by solving my X because it's the same variable and I know that these angles are congruent. Knowing they're congruent means I can set them equal. So 9X minus 61 equals 5X plus 3. I'll simplify and get 4X equals 64 and X equals 16. So now what I'm going to do is I'm going to just plug in some information. I'm going to just go ahead and use this 14y, since I know M and F are congruent, and add them all together, set it equal to 180. So 14y minus 12. All right, so we're going to do 39 plus 5 times 16, right? Because I now know X, plus 3 plus 14y minus 12 all equals 180. I'll simplify and get 39 plus 80 plus 3 plus 14y minus 12 equals 180. And then I'll just go ahead and combine my like terms. So I'm going to have 110 plus 14y equals 180. 14y equals 70, and y equals 5. That's a 14. Ooh, moving right along. Let's go to our congruent triangles. So, first things first, T is the midpoint of KE. So right here, T is the midpoint. That means that KT and ET are going to be congruent. It also tells you that KS and ES are congruent. Well, this is a shared side, so that means all three sides are congruent. So the Y would be side, 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 and we would say KTS is congruent to ETS, from E to T to S. We mimic that order. Next, T is the midpoint of AU. So these two sides are congruent. And it says the angle C and angle, G are congruent. And we know these two angles, ATC and UTG, are congruent because they're vertical angles. So if we follow it around, we have an angle, and a side. Angle, angle, side. And C, that matches with G. A matches with U. And T matches with itself. Cat is congruent to gut. Okay. EAT and RAE are right triangles. Okay, that's great. And that's all it tells us. There's not enough information here to prove these triangles are congruent. We know that one leg is, but we don't know if the hypotenuse is or another side. So this one we would be able to say we can't prove it congruent, not applicable, not congruent. Just basically, no, we can't do that. Okay, so LD comes through and it bisects RE. As a result, those two sides are congruent. The next thing it tells us is that DR and LE, they're parallel. So I'm going to turn my paper, maybe give you a better visual. Maybe you can see that this angle right here and this angle right here, if we were to extend this, those would be alternate interior angles, right? Here's one, here's the other. And we would see that these are vertical angles when we turn it back around. So why would they be congruent? Angle, side, angle. And if we go DRK, we'd follow that same order by going LEK. Okay, next up, angle C is congruent to angle R. Angle A is congruent to angle U. And then these are vertical angles. But three congruent angles don't mean that triangles are congruent, right? Because think about an equilateral triangle. All the angles and sides are the same. All the angles are the same, but the sides aren't necessarily the same, right? So NA, we cannot prove. Okay, last page here. Well, actually no, because, oh, yeah. Ooh, yay, this is going a little faster than I thought it was. Okay, so D is the midpoint of TG. So here's TG, here's D. I'm going to go ahead and mark those congruent. Oh, and it's the midpoint of KR. So those are congruent. And then hopefully now vertical angles are starting to jump out at you a bit. So I'm going to go ahead and write given. And TD is congruent to GD, definition of a midpoint. Then I'm going to look over here. It says definition of a midpoint again, so I'm going to say KD is congruent to RD. And then definition of vertical angles, so I'm going to say angle TDK is congruent to angle G, right? Because here's, these two sides are congruent, so I've got to follow that same order. Angle GDR. Okay, so now I can say triangle, let's just say KTD is congruent to triangle RGD. And that would be by side, angle, side. A side, an angle, and a side. My last thing that it was asking me to prove is KT is congruent to RG, and that would be by CPCTC. Okay, next up, P is the midpoint of HG. So here's HG and here's P, the midpoint. It also tells you that KH is parallel to GT. So these are parallel. And then the other thing I'm going to do is just go ahead and mark my vertical angles congruent in hopes that they might help me. And then I'm going to follow that vertical angle on that congruent side down and see that these two angles are congruent because they're alternate interior. So I'm going to take some of my information. First thing I'm going to do is P is the midpoint of HG, and that's given. My other given is KH is parallel to GT. And then H, oh, sorry, they did it in a different way that I did. These angles are still parallel. It's going to change my situation. Those angles are still parallel, or congruent, because alternate interior angles. So HKP and GTP, because of alternate interior angles. Vertical angles, I'm going to say HPK is congruent to angle GPT. HP is congruent to GP, definition of a midpoint. And last but not least, triangle KPH is congruent to triangle TPG. And that would be because of angle, angle, side. So because they called out a different parallel angle, a congruent angle, that's why it became angle, angle, side versus angle, side, angle. Okay, next up, Z is the midpoint of WY. So right here, that means these two pieces are congruent. Also, WX is congruent to XY, and they share this side, right? So I know a lot of information. I'm going to just start filling in. Z is the midpoint of WY, and that's given. And then WX is congruent to YX and given. Definition of a midpoint. Oh, okay. Well, let's jump back to that. Maybe I should have flipped that order, but that's okay. WZ is congruent to YZ. XZ is congruent to XZ. Well, that's reflexive. And the triangles are congruent by side, side, side. And last but not least, angle XWZ is congruent to angle XYZ because of CPCTC. And that's it, guys. We made it through your study guide. Less than 30 minutes. Nicely done. All right. I will see you guys soon.